Okay, Assalamualaikum warahmatullahi wabarakatuh. Good evening, everyone, and welcome to our today webinar, which is open for public. Today, we have our greatest honor to have our guest lecturer, Professor Shaligram Pokharel from Qatar University. Um, during this session, he will be presenting about supply chain management in natural gas industry. Um, prior to starting this event, allow me to remind all of you to have a quick look on our house rule, just to ensure that everyone is aware and uh, is do things that what we have set up from the very beginning in order to have our effective session today. Before we start, allow me to introduce myself. My name is Mohammad Ichsan. I'm the faculty member of BINUS Business School undergraduate program. Um, Today, again, we will have our great session to all of you, especially, of course, the students of BINUS Business School, which currently already, attending this session. And this session is also recorded live on YouTube. So then, for those who cannot join, maybe due to the limitation of this Zoom session, it's still, the YouTube channel is still available for you to watch. Okay, before we start, I would like to have my humble request to Dr. Ahmad Shamil, the Dean of BINUS Business School International, to open this session by saying a few words before we start this webinar. The session is yours, Dr. Ahmad Shamil. Thank you. Yes, Pak Ahmad Shamil. Okay, he's there. You are still in mute, Pak. Okay. Admin, can you please?
Thank you.
Okay.
Yes. Okay, thank you very much. I couldn't speak before because I was muted. Okay. Anyway, thank you very much. Good evening. Assalamualaikum warahmatullahi wabarakatuh.
Good evening.
Okay, thank you very much first for our special guest, Professor Shaligram Pokharel. We are delighted. We are very lucky to have you here tonight. Okay. And do you know how many people register for this event? Okay, at least 1,800 people. Wow. At least. Wow, this is wonderful. Okay, because of your name, you are famous. Okay, so we should have a second lecture from you. Okay, to attract more people.
No problem. Yeah.
Okay, thank you. And some of the people, okay, some of the guests here, okay, some of them are here with Zoom. Okay, and then some of our guests will be on YouTube. Okay. Anyway, okay, this is a great opportunity for us to learn from you, your experience, your knowledge about what happens in natural gas industry in Qatar. Okay, definitely this totally different with what happens in Indonesia. Okay, and I don't want to speak a lot. Okay, now it is time for you to exchange, okay, to deliver the information, to deliver your knowledge to us. Okay, thank you very much. Thank you very much.
Thank you, Dr. Ahmad Samil. I think again we cannot wait further, but allow me to read some quick profile, some words for your quick profile, Professor. Okay, so our guest today is Professor Shaligram Pokharel. He is the professor and coordinator of Industrial and System Engineering Department, Mechanical Industrial Engineering Department of Qatar University. Dr. Shaligram Pokharel joined Qatar University since August 2010, and prior to this, he was active in Nanyang Technological University in Singapore as assistant professor until from 2000 June until October 2005. Professor Shaligram holds his bachelor degree in mechanical engineering with honors from Regional Engineering College in Kashmir, University of Kashmir, and his master degree and PhD in system design engineering from University Waterloo in Ontario, Canada. His research focusing on engineering management area. He has done a lot of research in logistics and supply chain, energy planning and modeling, as well as project management. He has been publishing a lot of papers in these areas, and also he used to be my mentor in Project Management Institute. I think without any further ado, this is your session, Professor. Thank you.
Thank you, Professor Shamil and Professor Ichsan. Thank you very much for inviting me to this session. I'm very much honored to be able to talk to you what I know, basically. It was from the heart. I mean, most probably, some of the things that you will see in my presentation would be from my own experience, from my own research. And the idea is to see how we can look at the simple things and do modeling and make things much better, make lives better for many people. So that's why my topic is about supply chain dreams. Dreams are followed by some people. When they follow up and when they materialize some of the aspects that they want to work on, then the supply chain follows from there. So I will start from a generic example of dreams, about dreams, and then I'll move to two cases on natural gas industry. I'll talk about the generic part of it and how we can model, put models in this generic type of natural gas. And then I'll talk about how do you supply and how do you model it in this one. So the three main things that we'll talk about. First thing is about the dreamer. I'll take you to a very different perspective. I will not talk about natural gas there. Then I will talk about how dreamers lead to a different kind of situation in the market. Then I'll talk about the importance of natural gas supply chain. How does it work? And then I'll talk about how do we model basically the supply, which we call natural gas supply. And by the way, Qatar is the first one in the world now which supplies the natural gas. And Japan is the first one which is importing the most. And unfortunately, I don't see, most of the exports from Qatar is going to China. And I will show you those parts later. So I will start with dreamers. I mean, I will give you very simple type of examples. When people didn't have personal razors, what's the meaning of this one with respect to, for example, natural gas? There's no relationship, but there is a relationship. We'll talk about that. You see, when there is no personal razor blade, back in 1800, maybe before that, late 1800 and before that, people used to have, when you have to shave, you have to have an occasion. And then you need to go to the barber or maybe some people who are specialized in that one. And then they will shave it for you to your taste, but you have to wait, basically. You cannot do what you want and when you want. There are things that has to be done in a very different way. So remember this, you cannot do what you want when you want. So then around late 1800, a person called King Zealot, there are many people involved, but I'll look at this one at the end point of it. He basically developed a model, which is a business model to use thin blades in order to save. Okay, so thin blades, and remember business model in order to save. So before thin blade came into picture, there was a very small production system for the blades. They were specialized and they were sent to particular people. And then the particular people used to be the barbers, and they will take it and they will do their business, and then that's it. But when this person came into picture, when he patented the blades, and when he created the business model, then the blade went to everybody's hand. So the market expanded from limited number of people to millions of people, and they sold millions of those blades and the safety razor within a year, and then you can look at the history later on. So what he did was he created something that he dreamt. Okay, so dream is very important. The second is about sewing machine. Before the sewing machine came into picture, there were thousands and thousands of ladies and gents who used to make dress for you, for us, that time, okay, if we were born that time. And they will make things that we need, the way we need, with the cloth that we need, and not at the time we need, by the way. Even a shirt like the one I'm wearing now, it used to take about 5 to 7 days that time to stitch it. And you have to get the material, then you stitch it, and then you keep it on for some time. But then in 1830, somebody called Bartholomew, he got involved in developing something called, we call it sewing machine, but that time it was not sewing machine, okay? So he developed something, and then when he developed and put it in the market, he had a small tailor shop in France. People started agitating against this person, and he almost died, by the way, because that time people thought that when you have this kind of machine, all the jobs of thousands and thousands of people who are stitching the cloth and the dress and they're selling to the customers, their job will be gone. So he just kept quiet. He could not do anything more. But in 1951, after there were several what you call development took place. And in 1851, Singer came into picture, and then he developed the first crankable hand machine which worked with the two threads. And then after that, things changed. So dreamer changed the things. So what we are knowing from these two examples is that if you dream, you lead the same end product in a different type of back-end processes. The third one I will talk about is a car. Okay, cars developed in about 1800 or 1860, 70, maybe a little bit later, because internal combustion engine came into picture a little bit later. So let me go here directly, and then let me talk about this particular company. And this company is very much interesting to me because this is how things started changing. Panhard and Levasseur in France in 1886, they registered a company to make automobiles. And they didn't have engine. They got the engine for Daimler, and they started making the cars. Okay, they will make the cars because there are people who can make the cars. Okay, there are people who can make the tires. There are people who can make seats and all those things. But then it is not very interesting because so most of the things being made was made by those people who are skilled in that particular company. Then came in 1894 a person called Evelyn Henry Ellis from England. He traveled to France to this company and he said, I want a car. Okay, an Englishman wanting a car, and that is from a French company. So he said, okay, I need a car, but I need some specific things in my car. He said, I want to have the lights in this particular place. I want to have my steering in this particular place. I want to have my clutch in this particular place, whatever. He basically custom designed the car. Okay, the people in that company, they were aware of what needs to be done. So they were able to deliver. So he came back and he said, okay, I want to try my car. So he ran with his car. He drove his car around streets in France. He made a performance testing. That's what we call it today. quality checking, inspection, whatever he could do that time. So he did that during that time. And then he said, okay, change few of the things. So he changed, and then he took it to England. When he took it to England, that was the first car ever taken to England. So when it was there, the competition was with the horse carriage. Okay, they were beautiful horse carriage. Many people rode there and they enjoyed horse carriage. When the car came there, it was difficult for them. And he drove and drove, and he drove many, many miles. And then finally he got into, into the parliament, and he said that, okay, we need to change the speed of this one, because horse carriage didn't want him to increase the speed. I mean, because that way there's a competition between the car and the horse carriage. But he was successful. It went to 12 mile per hour speed for the car. Today, that is something like walking. So if you look at this one, for example, on the right-hand side, there's a picture of the exact car. It's in a museum over there. And then what happened after this one, people started liking the cars. The order started to grow. When the order starts to grow, then you have to standardize the parts. You cannot have, same skilled people in this particular company making all the parts all the time. You cannot cope up with demand. You have to ask a host of suppliers from somewhere to make those standard parts and bring it to Panhard and Lapasso, and then start making the car. What they did, they created a chain of supply. In the first one, when the safety razor was developed, the demand changed. The demand went from barber to even a person, a male or female, it didn't matter. In the second case, the demand went from stitchers who were stitching the cloth to the tailors. And the demand went from individual people waiting for 5 days to stitch a shirt to immediately needing a shirt. Things change. The supply chain changes. All supply chain, in my view, are brought about by those people who are innovators. So we need to dream. Once we dream, next thing follows. So how do I model this one, basically? How do I model this, okay? So in terms of modeling, if we look at from today's perspective, we make everything right. We want to make everything right. Although things don't become right, but we always try to make it right. So we want to take right materials. We want to get at the right quantity, at the right place, at the right time. So this is the first part we start with. Then we go and process it. And then when we process it, we supply to the next one, which could be the right customer. We have to supply to the right customer at the right location, in the right quantities, in the right qualities, at the right price. Okay, so this is before anything can be done, because when the materials have to be processed, before it is produced on some parts, all things have to align at the right quantity, right type, right price, and everything. So the second step is, for example, when we supply for the production has to be produced, system has to produce the right product with the right type of equipment in the right quantity. We cannot, produce more at the right time. We have to produce, and with using the right resources. So any ingredient that goes to the product, basically, if it is not right, the final product you are going to get is also not going to be correct. So when you produce it, you have to distribute to the right place. I cannot see on the right hand side. Let me see. To the right market, in the right quantity, at the right place, at the right quality, and also through the right packaging. You see, packaging is also very important. And these things, small things, make a lot of difference in terms of the consumption of the product at the end. So then, where do we add the value? Because when we plan supply chain, we're looking at adding value. We add value in supplier's place, which is on the left-hand side. We add value on the producer place, which is on the right-hand side. We add value on the distribution place, which is on the right-hand side. Anytime when we add value, the cost of adding value should be much less than cost of getting the benefit out of that value. So that means when we design the supply chain, we must look at what is the difference between the value in terms of the benefit, whatever that benefit is, and the cost that we actually use for that particular value. That's not end. You know, when the production system is going on or the distribution system is going on, we need to understand how much should I produce? How much should I produce? Because I cannot say that I will produce 20 and then I stop. I need to run my system because I have resources, I have people, I have raw material. So the second thing in the modeling comes into how much should I produce to order? So there's a demand. So I fulfill that demand immediately. And how much should I produce to stop? There's no immediate demand. So the demand is going to come next. So we need to optimize the ratio for production. And then this type of optimization to build to order and to build to stock is called supply chain positioning. Where do I position myself? How much should I produce? Where should I produce? And how should I produce? Becomes a factor that we should consider in terms of modeling of supply chain. So it means that there are many things that we can do in terms of modeling a particular supply chain. And that's not enough, We need to look at the materials, for example. We need to look at, should we use replaceable material? Should we use recyclable material? Or should we use less material? In some cases, even if you use less material, the final product is not going to change. So what is that? Should I use the material which can be recovered? So when the parts is actually used, can I recover it and can I reuse it? Those things also can be understood. What about the processes? Should I use replaceable processes? So maybe replaceable could be in, for example, changeable process instead of manufacturing. Maybe I will just do assemble. Instead of testing, I will just remove that testing part to somebody else. So my process basically in supply chain is driven by the efficiency, effectiveness, and cost. Then I can change the process the way I want it. Okay, so can it be replaced? Can I replace my manufacturing system? Or maybe can I remanufacture? So some of the parts which is already existing from the existing product, can I use it for remanufacturing? And what about pollution? Nowadays, pollution becomes a very important issue. Climate change, there are different events that's going on every year. And we need to also look at the pollution. So how do I control this one? Is it the job of supply chain manager or it's the job of somebody else? We, as a supply chain people, we can also model that one. So there's a complexity. Basically, we need to understand the analysis part of it, what we need to do. For example, in terms of variables, optimization, which is basically two-dimensional analysis normally we do. And what we need to add is the three-dimensional thinking, what's going to happen? What's our vision? What's our horizon? What's our strategic thinking? How are we going to use the supply chain over a long period of time? Because it's an investment, it's a CapEx, capital expenditure. So we need to understand those values in terms of providing a good supply chain for a particular dreamer's product, okay? So let's move to now natural gas, okay? So now what I said is that if you have a dream, when you realize the dream, you have a supply chain, you can model the supply chain in many, many, many ways. So now let's go to the very basic things that we use and I would call NG dreamers. These dreamers, basically, they dream about the products, different kind of products from the material that's already available. So let's see how it happens. So when you have natural gas, for example, you have upstream. When you explore, you develop the field, you have production system, you have operation system. You have then midstream, then you have transportation, processing before it turns into final, raw material. Then you have downstreams, which is manufacturing of petrochemicals, manufacturing of products. Then it will go to downstream too, which is packaging, wholesaling, retailing, marketing, and then finally utilizing. Normally, in our supply chain, many of us miss the last part, the downstream utilization. If we look at it correctly, that's where maybe most of the value can be recreated. So in natural gas, when it goes from gas to solid over here, we are looking at a dream that can be realized by using the natural gas in order to make the life of the people very easy, life of the people very effective, life of the people very efficient. How? So let's look at something over here. This is a house, okay? And if you look at this house, for example, this is cladding over here. This is roof trim board over here. These are roof materials over here. This is window, window glass, window frame, window linings, sorry, the side linings over here. They are all the products from natural gas, by the way. Okay, it is from petroleum products, but we're talking about natural gas also. Then if you look at this one, on the top of one over, this is a roof. This is the roof. This is the floor tile. This is the injection. This is PPE. This is the tent. This is a car dashboard. This is saline water disposal in a medical, in any hospital. These are PVC pipes. Everything is made of natural gas. So if we don't dream about this product, the upstream part cannot happen, because you can produce, but if it is not used, it's a waste. Nowadays, if you release natural gas to the air, it's going to be a greenhouse gas. It doesn't end over there. It's one type of product. But let's look at the second one. So if you look at this one, polyethylene, this is for transportation of material, water tank. This is for picnic. This is for polyethylene pipe. And if you go further, even plastic for containing the food, your garbage bags or your plastic bags for the shopping. You look at your fridge, you use this cling wrap. You have this boot for nowadays COVID, so you have to, protect your shoes also. And this is caustic soda. This is even supplement, hydrochloric acid supplement. I was not knowing this one, because how can you eat hydrochloric acid? Yeah, there is a supplement. And then even makeup, for example, materials, they are all using somewhere plastics, somewhere the product from natural gas. And if you look at this one, this is a knee replacement. In that one, this part, which is supposed to be very smooth in order to move our knee, that's also made of polyethylene. So if you look at the product, the type of product, the number of product is enormous for one or two raw material. In this case, chlorine, which is from seawater or salt. The second one is natural gas. Okay, so how we look at all these things. So if we look at this one, there is not one type of plastics we have. We have different range of plastics. I'm not going to go through this one. Even something like a drinking water bottle, which is PET, you use one time and you need to throw it. And then there are HDPE, vinyl, PVC, they call it PVE, PVC, LDPE, you name it. Okay, there are many products which are mixed and matched in order to develop the final product. But the interesting part in this particular case is almost all of them are recyclable. They can be recycled in terms of our class. So we can have a shirt made of plastic. We can have a file. We can have many things made of plastic. We can have rebottled. Okay, we can have any type of trash cans. They can all be recycled and they can be rejuvenated into the economic system. They can be brought back. So the beauty of natural gas is if you utilize it properly, then we can bring it back to the system to utilize it again. So the point is here like this. So in this particular case, this is from Indonesia, and it's very recent, by the way. And then the idea is over here, there's a lot of waste over here. It's collected. What to do? The collected waste is going to be converted into pavement blocks. One idea. So after pavement blocks, maybe once it starts wearing and tearing, you can bring it back and maybe you can make it again the pavement blocks. But the main thing here is the recyclability and reusability of natural gas, by the way, is very important for us in our daily lives. So what we're doing over here is, can we recover the value that we have used in a particular product and the value coming from the natural gas, its processing later on? Can we do that? So let's look at this one. There are a few final products over here. These final products need raw material. So like polyethylene, chloride, low density polyethylene. These are chemical things over there. And then if you go further, you have to do polymerization. You have, these are coming from petrochemical industry. Those petrochemical industry do some processing, and those processing is coming from, some product. They have to be develop some product through cracking, whatever. And then, okay, finally over here, we have salt, we have seawater, we have air, we have fuel gas, and we have natural gas. And all these things are actually driving the whole products that we are working over here. So these are all in the nature. This is all we develop. Okay. So now, where is supply chain over here? The supply chain over here could be anywhere. If you look at, for example, the processing system, you need to procure the materials, the equipment, the spare parts. That's a supply chain. You need to procure the catalyst. That's a supply chain. You need to procure, raw material that has to be used, in mixing things. That's also a supply chain. So supply chain drives everything. You start from the beginning until the end, and from also end, we also drive it down. So there is supply chain everywhere. So if you look at from the specs of supply chain, there is supply chain everywhere. This is the beauty of people who are working in supply chain. They need to look at everything from the perspective of supply chain. It can be done. So what about complexity over here? What's the 3D complexity? Thought process has to be there. We need to understand how much is the demand for these products on the right-hand side. Then if there is a demand, if we are using that for, from the gas, how much to extract? And how to size the plant, how much should be the petrochemical industry plant that we need to develop ethylene or this PVC or everything. And do we have a flexibility in production, because all the time the demand is not there? How should I do it? How do I balance the production of one type of product and another type of product? You see, it goes, the natural gas goes in, the salt goes in, then we get many things. We got polyvinyl, or we got polyethylene. They are all depending on how much we put into the system. So how much we should put into the system? Or it's a byproduct which is called ethylene. It can be used to produce polyethylene or vinyl chloride. So how much to use for polyethylene? How much to use for vinyl chloride? Because these are raw materials to produce the final product. So we can use a method called postponement. So in supply chain, postponement becomes another process. Okay. So there are many papers you will see who are working on postponement part of it. And is there something earlier, producer responsibility? So in supply chain, maybe you can also look at how much of the product has to be recyclable. So I produce it, can I recycle it? Or for what it is actually recycled? So which part has to be recycled, which part cannot be recycled? It can be designed right into the beginning. So we can define those things before it is actually produced. Or in some cases, you have to take back those products, and what is the recovery? Is it 80% recovery? It is 20% recovery, 30% recovery? We can also define that one, but we need to model all these things, okay? Then how to recycle, then how to recover, how to reuse, and how to analyze these products and put it back to the market. It forms another chain, and that's called nowadays circular economy. So basically what we did is we processed the natural gas, we developed the raw material, raw products, basically intermediate products, we developed the final product, we use the final product until we need it, then we recycled it back to the mainstream again in order to generate the economy without losing much of the material on the process. So we created new type of economy. So you see the supply chain moved in a different direction. So I will go to the next slide, then it will be clear. So on the left-hand side is natural gas and others, for example, salt and catalyst or other things. Then it goes to petrochemical products. We'll develop ethylene, PVC, or QVC, whatever we produce. Then when we produce, we take it to the end product to develop the final product. So we develop final product, we take it to distribution and storage. We have retailing, and then we have customer who are the utilizing part of it. So this one is number 3, if you remember, downstream number 3. So this is initial supply chain. All the dreamers, basically, they stopped over here. You utilize, after some time, you use it, and you basically throw it. Okay, that's the end. Fortunately, in natural gas, we can extend the supply chain further. Okay, so if you look at this one, I can defer the disposal. Defer the disposal, I can minimize the disposal also. How should I do it? So I can create a collection system. Okay, I can take back parts either through the sellers who sold them or through a independent collector. Okay, I can do that. So I have started collecting it back for something. Then after I collect it, I can inspect, I can sort it out, I can put it in warehouse, whatever happens. Then after we do that, I can reprocess, I can use the spares. In natural gas, normally spares is not very applicable, but it can be done. Then I can recycle, and then finally I can dispose. And when I have reprocessing and reuse, I can use it with the same distribution system, or when I have spares, something to be done, I can use that for reproduction or final production system. Not that only. This one is basically reverse logistics nowadays. I mean, we call it reverse logistics. It used to be there. And then when it comes back to the same original what you call product, and you restart using everything, reprocessing, spares, recycling together, it creates another sort of economy. We define the kilometers, the distance travel, we define the process, we define the cost. Same thing in the upstream, same thing in the downstream. So the modeling part can be started in any phase of the supply chain when we go for starting of the material to the end of the same material. So we bring back the material to reinvigorate the same supply chain again. So what is the main problem here? Basically, to define the cost, effectiveness, and efficiency. How many times I recycle it? It might be, chemical content that will drive that one, or it might be something else that will drive this one. But we need to understand how I model this in terms of developing the value out of the supply chain. Remember, we have to create the value. That's what the main part was. So if you look at research agenda that we can do from here, what is the take back price of raw material? How much should I pay? Somebody brings the raw material which is already finished. How much should I pay? We did a study before. We did a study by using different kind of models, and we tried to define how pricing has to be done for a product which is used to be for remanufactured. And we also looked at what should be the acquisition price, for example. Okay, so pricing of used products, pricing for acquiring it. So I have a collection center. How much should the collection center pay to the customer who is giving back that particular part to me for reusing it? Okay, the part may not be reused because of inspection. Maybe it is too much rotten, so we cannot reuse. But I need to be able to provide a price to the customer right at the time when the customer is giving back to me. So we can model that one, and we have done that. If the products are return free, maybe there are processes that we have to look at it, or if the products have to be paid upon return, there's also another pricing that we have to do. And then what about capacity of those circular economy or reverse economy? What should be the optimal capacity for collection? How much should I collect at a given time? How much should be the capacity for sorting of the materials? How much should be the capacity of parts? Okay. How much should I reuse it? How much should I send it to the market? What about the capacity for reproduction of the material after getting the spare parts? This can also be used for modeling process. And we have shown some example over here. They have already published, so you can have example over there. So the research agenda over here, the other one is about how much is the emission, by the way. Can we control the emission? Yes, we can do that. We can model it. There are, policies now because of conference of parties. They will say that, okay, this is the cap, or if you use more than this carbon dioxide, I have to ask you to pay. You can trade off. You can do many things, right? So there are rules, basically. Depending on that rule, we can define the supply chain. It can be hybrid supply chain, which will take back and produce basically new material, or it can be dedicated closed loop supply chain. Everything is recycled, only new, very small new element is going into the picture. That can also be done from the perspective of emission. So when we do that, our supply chain for the same final product is going to change. What about maintaining the petrochemical system or maintaining the production system? There's also a supply chain over here. I need to understand how many people I need to hire in order to maintain my production system. And I need to also understand how many should be trained in which type of maintenance. So not everybody is able to maintain all the equipment that's available in the petrochemical industry. So maybe I'm an expert in boiler. I may not be able to do anything in radiator, for example. So I need to understand how many people I should train so that they would be able to maintain my system throughout the production process, and how much space inventory I should keep, because these inventories are very expensive. Should I keep them? Because if I keep them and I don't need them, basically we're tying up the cost. So how much should I keep them? That's also a point that we need to look at it. So if I'm capable, if my company is capable of repairing some of the parts, maybe I don't need a lot of spare parts inventory. But if it is not, maybe I need to have more inventory. So we can have a joint pricing and joint what you call capacity modeling in order to understand how much we need to invest in terms of maintaining our system. Just maintaining, not operation, not production, okay? Maintaining our system. So this can also be modeled. So you can see that there is a spectrum of modeling process that starts from the beginning, that goes until the production system, or that goes until the take back of the product. So that's my first part. In the second part, I will look at one modeling process, because now Indonesia has also invested in LNG supply. They are, I think, 6th largest exporter in the world, if my data are correct. Then we need to move gas from one point to another point. In our earlier case, we used to have a transportation chain with a pipe. Okay, so you just move gas from place A to place B. That's it. It's a dedicated supply. That's it. But now it's not going to happen. So things are demanded at different location at different time by different type of customers. So you need to supply in a different mode. So piping is not always viable. If it is viable, it's good, by the way. It's a long-term investment. Then we have to do liquefaction. We have to liquefy natural gas to make it liquefied natural gas. And then we need to deliver by ship. And they are not cheap, by the way. And if you look at how much is going last year, 2018 data, this one, 316.5 million metric tons that have been traded in terms of LNG. And if you look at the growth, 28%, that's about 10% growth every year. That's quite a large growth. And if you look at the cost, over here, if you have a vessel, for example, one vessel can cost you about 195,000. One vessel per day, this is by the way. And this means, let's say if you are selling $2 per a million BTU for gas, 1.195 is about $1.9 already. So there's a pricing that we have to do. So if the price of gas goes down, the chartering also goes down, okay? If the price goes up, the chartering goes up. It means that a large portion of supplying natural gas is consumed by the transportation part also. So by just for indication, I think the 195,000 over here has come down to about 50,000 or 54,000 now because of low demand. So there's always cost to do this. There are always different type of vessels that we can use. This is a individual container. This is a compartmentalized container. This is in Singapore liquid natural gas tanks over here. So you can see that, okay, it has come to the terminal, and then it's going to the storage capacity, and then it is going to be sent to the consumers. But there is a problem over here, because that's what we have to come through the modeling process. So if you look at this one, this is just for Qatar. The largest is China, then India, even Pakistan, they are Korea, they are importing a lot of LNG gas from Qatar. And if you look at how do I create this supply chain, how do I model it, we have to look at the changes in demand. Many of us may not know that demand can be blocked for a year or 2 years, but every month it can change. Every 15 days or every 2 months it can change. So there is a commitment, but there's a commitment change and fluctuate. So 2 years, for example, I take 12,000 metric ton, but January maybe I will not get anything, but February I'll take more. So these are seasonality. So there's a window of demand which can change, and the supplier has to understand that part of it, because they have to plan in such a way that the cost is going to be minimum. So the demand which changes may or may not be known in the beginning, and we cannot store it all the time. And there are multiple customers, okay? You cannot work with only one customer. There are multiple customers. They need multiple type of quantities at multiple times, and then at different time windows. So we cannot supply any time that we like, okay? Maybe it's good to supply when you need by a vessel which is sized exactly to what customer is requiring, but that's not possible. So there are many factors to look at it. One is the number and capacity of vessels. There are only limited number of vessels, and their capacity is also limited. The vessels cannot go at two places at the same time window, so we need to have two vessels going there. Maybe once the storage vessel is emptied, it has to come back, return to the same original position. We have a time period. Vessel arrives at one port. Then if there is still some gas, it can go to the next port. Otherwise, it has to come back. The route from one customer to another customer is already defined. Vessel supplies to one customer. The balance inventory is known. Then it can be supplied to next customer. There is a berth capacity. So in all berths, maybe the large vessels cannot go. LNG vessels cannot go. So there should be smaller vessels for unloading part of it. Or maybe they have to be maintained. So all the time the vessels may not be available. So we need to consider these things as modeling process. Then we need to look at the cost. We need to minimize the total cost of supply. And if we supply early, there is a penalty. If we supply late, there is a penalty. So we need to look at that. If we supply less, also there is a penalty. So we need to look at these things in terms of our modeling process. Then demand changes. When the demand changes, in the long-term contract, maybe there is oversupply. What should I do that oversupply? Because the ship has already gone from the supply side, it's going to the demand side. In between, the demand changes. Maybe when you have 2 months window in terms of voyage, maybe that can happen. Okay, so decision-making becomes 3D. Decision-making becomes very important. So we can have different kind of models. We can have split delivery. We can have one shipload delivery. We can have capacity of the tank, but we need to maintain certain capacity. For example, if we don't maintain more than 70% or less than 10%, then there will be movement of gas, and it's going to be trouble for the ship. It might topple, or it might create a structural problem in the ship. So we also need to look at those kind of situations when we're looking at the supplies. Then what we did was, just to put things in perspective, we tried to understand what is the best modeling process. So we looked at the current model, and we developed our own mixed integer programming, and we solved it in Simplex, which is a computer software, and we developed our own heuristic, vehicle routing heuristics. That's what we call it. We looked at different types of vessels, class A, class B, and class C. And those class A, which are smaller, they can visit up to 8. Class B can visit up to 12. Class C, which are much bigger, can visit up to 16 ports. And we looked at the contract of supply. We look at the demand that changes in different seasons. We look at 6 seasons, every planning period. And then we try to solve the problem. So what happened? After we solved the problem, this is published, by the way, in this one. We looked at 3 different types of ships, 6 different types of seasons, and where they are moving. So these are 8, 12, and 16 ports they are moving. And we got the first lower bound by relaxing the modeling process. So it is not integer. So one ship can be broken down into 2, basically. Okay. Then we run that in Simplex, and this Simplex running is 24 hours minimum. Okay. The results provided here is 24 hours. Whatever we got in 24 hours, that's the result. So we look at from the ideal case, the cost is much more, which is about 34% more. Then we use our heuristic. We use about 780 seconds to solve this one, and we got only 12%. Okay, so our solution is much closer than the solution developed by Simplex, a large-scale solution produced by Simplex, compared to the ideal solution. That means these are much more closer by using the modeling process that we have done in terms of calculating the total cost of supplying to different customers the liquefied natural gas from point A to point B. And we also compared whether it is split delivery or non-split delivery. So we promote non-split delivery because of the large size vessels. But what we found is that maybe in some cases, split delivery is good if there's not much seasonal changes, or if the demand is not too erratic. Then maybe it is small. Split delivery might be better, but in other cases, non-split delivery is better. Our solution is about 4.2% better in in split delivery. So it shows that this 4.2% could be millions of dollars, by the way. So we could see that supply chain, when we have to supply by using the natural gas in terms of liquid, then we also can have a big supply chain over here. Okay. That's all I have to say, by the way. So let me recap everything. Supply chain, every supply chain follow innovation. Innovation is in terms of products that we develop and the production that follows to develop that particular product. The production system goes with the supply chain. So everything has to be modeled, identified, optimized, made it effective, efficient, less pollution, everything that has to be done. So effectiveness and efficiency can be obtained through good design of the supply chain. So most of the papers that I have shown to you are basically focused on design. The planning and modeling process is complex. Therefore, supply chain becomes when it becomes larger, modeling process also becomes complex. So our aim in a supply chain is to first conceive what we want to do, then to model. When we model, we monitor the values. We monitor how it works. We control whenever we can. And if we are not able to do that, we have to generate new idea. We need to dream again. That's why supply chain dream never ends. That's what I have to say. Thank you very much. Yes, Pak Ichsan? Any question? Yeah.
Thank you very much, first of all, Professor, for very, very, very valuable speech.
No problem.
It's I believe, at least myself, I've learned a lot from this session.
Thank you.
And I believe the rest of the participants will have the same experience like mine. I think I would like first to have our organizers, to open the chat for for questions and answer during this question and answer session. Okay. However, I have already one question for you, Professor.
No problem. No problem.
Okay. So the first question was, okay, how about the product stewardship? Okay, making product safely in production, distribute, use, and after use. Many international consumer goods, they don't care about recycling, recycled packaging, which is made of plastic, which is one of the major pollutants of this earth. So the main question was, how about the product stewardship?
You see, I mean, when you look from the point of view of natural gas, okay, there are two viewpoints over here. If you look at from the user's point of view, the users will think that, okay, this is a plastic, it is, it has to be thrown. That's not true. The thing I have tried to show is that everything can be recycled. When it can be recycled, it can be used for generating products which are much more useful. It's possible to do that one. So the way to look at it in this supply chain is that we need to not only look at from the point of view of supplier, which is supplying the final one, but also from the consumer side of it. So if the consumer becomes aware, then, I went to Czechoslovakia, just last year, Netherlands. There are machines where you can use your, for example, any plastic bottle, you go there, you can just dump it and you get a penny out of it. This is education. The education is leading to looking at the final product as the raw material for the next product. If we don't have this mindset change, things are going to be very difficult.
Okay, thank you, Professor. And I hope the question is answered as per expected by the participant who raised the question. I have another question already for you, Professor. The second question is, in terms of supply chain dreams, in the next coming 5 years, what will be the dream factors that will be enabling and delivering agility and further efficiency in natural gas industry? Then given those factors, what can be benchmarked for other industries?
I think in petrochemical, natural gas is a feedstock for the petrochemical industry. I mean, I'm looking from the point of view of petrochemical industry. What is efficiency? The way it is run now is, at this point of time with this technology, at the current state, is already efficient technology, because you cannot compete without that in the market. What can happen at the next phase is the next wave of innovation. Innovation could be in terms of material generation. Maybe, let's say, for example, we go for a particular type of sole, for example, okay, shoe sole. Maybe we can reuse that material to innovate, use less of them to get the same value, or maybe we can add some additives in that one in order to generate the same sole, but with more, feeling for walking, for example. What is the next one? If one of the good thing about petrochemical industry is that because it is based on the raw material, and it has to work through the generation of different products of the raw material, is an efficient method, by the way. What is the benchmark for other people? Don't waste any raw material. That's the benchmark. Don't waste any raw material that's coming in. Try to maximize the use of whatever you get, minimize the waste. That's the benchmark the other people have to do. The second thing is that if you look at petrochemical industry and other industry, there's a big thing called shutdown in petrochemical industry. They shut down without looking at anything, and they rejuvenate the whole production system with new technology available at that particular time. Let's say, for example, there's a reactor. That reactor is shut down every 6 years. So when the new reactor comes, after turnaround, the new reactor is much more efficient than the old reactor. So you have rejuvenated the technology, and not to say that technology is also being developed by somewhere to make it much better, much faster, much efficient. So continuously reworking on the technological side, using that in terms of production system should be the benchmark that we have to take in order to develop a better supply chain in the future. That's my take.
Okay, thank you, Professor. Professor, do you mind for extending another 5 minutes, because we have another few interesting questions.
Yes.
Organizers, please be informed accordingly that we will extend another 5 minutes. Okay, so the next question is, is very interesting. Indonesia is an archipelago country. How to bring natural gas from the gas source remote area to another island, whether the market willingness to pay only $6 per MMBTU, to build LNG and regasification infrastructure will cost a lot. So means, it's like the cost of adding values compared to, the benefit that we will get. What do you think, Professor?
Actually, I mean, 6 is very optimistic figure, by the way, now. It's about 2 or 3, maybe 4 now, 3 or 4. The idea is like this. I mean, when you have natural gas, it can be developed through this floating platform, floating production, storage, and offloading system, okay? It can be done. It can be brought back to the island for keeping the production system or petrochemical industry in the island. The technology is already there. The capex comes into the picture. You see, in order to develop this type of industry, we need to have a guaranteed market. So first thing is, the supply chain comes into picture. Now, if, for example, in natural gas, in Indonesia, we want to explore the natural gas, we want to develop the petrochemical industry based on that one. I think the first thing is to look at how much of that natural gas can be used for petrochemical industry, and that petrochemical industry, how much of that can be used for final product for use in Indonesia. So my take would be, if there is about 40% of that product can be consumed in Indonesia, I think capex is not a big thing. Okay. The exploration cannot be everything together at the same time. You might have, 12,000 tons, exploration now, and as you go on, you can increase that later. The main thing for a country like Indonesia, we need to look at is we need to develop our own supply chain. We need to develop recyclability of that supply chain. We need to convince people that our product is the better product, and we used to do this one. So if we have this capability for consumption, of course, Indonesia has that consumption capability because it's a big country. There are many people who can afford to do that, and plastic is not that very expensive. And if we can do that, for example, by creating new product, for example, in homes, for example, if we start creating more plastic than timber, most probably natural gas is going to be much better. Okay, the exploration of natural gas is going to be better. The price is very difficult. We are doing some pricing mechanism, and we looked at Brownian motion. Every time it changes like this. If you look at 1 day window, it might be changing like this, but every minute window is like this. It's very difficult to control because when you have externalities coming into the pricing system, it is difficult to maintain. But if we have a guaranteed market inside, it's easier to maintain. Okay, so price is different thing. It definitely impacts the capex, but it is not that it cannot be done. Just to give you perspective, Qatar is about 78, 79 million metric ton per year. It's expanding to 110 million metric ton in about 2 years' time. Why? There's a demand. You need to create a market. So that market has to be created.
Thank you, Professor. So let me again try to manage this time. I have another 2 interesting questions, but have a look whether we can still make it. The next question is, what is your opinion about the threats where there are competitive energy more efficient? For example, as you said, in chlorine industry from brine, but we also produce hydrogen, which is used for combustion as well. We even try to reduce use of natural gas. So what is your view of the threat?
What is the threat of using hydrogen gas or something like that? I could not catch up.
So it's like, comparison between this natural gas, compared to some other, resources like hydrogen, for example.
Okay, natural gas we're looking at in terms of feedstock here. Natural gas can be clean and it can be used for burning, okay? So then there's a propylene, butane, whatever that can be created later on. Hydrogen is a byproduct. It is a byproduct from even natural gas industry, petrochemical industry, any petroleum industry. Hydrogen is not independent, ingredient found in the air. So competition could be in terms of, for example, if you have a natural gas, if you have a hydropower, maybe over the long term, hydropower may become much more cheaper. But if you look at the petrol or byproducts, which is using the petroleum products to burn, maybe I'm wrong. I don't think there's a competition on that one, okay? We have to become more efficient, by the way, in any case.
Thank you, Professor. So I think this one should be the last question from us.
Okay.
Another interesting question. So how does considering that we are still, struggling during this COVID-19 pandemic, so how does this new normal condition affect the supply chain of natural gas industry right now? How does the development of renewable energy affect the supply chain of the natural gas industry? And last but not least, what is percentage of influence occurs in these 2 conditions above?
You see, new normal is, we don't know the new normal yet. We are in the plateau. We are somewhere. We are trying to find the new normal. We don't know yet. It's a situation where we're thinking that it's going to be new normal. Okay, so that situation still has to come. So when it comes, then we might be able to find a solution. But I will give you some indication. The first indication is definitely the production system has slacked. The consumption has slacked. The perception of people in terms of product has gone down, okay? But you see, this kind of situation happened before also. There was pandemic before also. People were, having the same kind of feeling. So what happens is that the one type of innovation gives way to another type of innovation. So maybe instead of focusing on small type of uh, regular type of products that we do now, maybe the new normal would be new products, a new way of thinking. Maybe it will go for more medical type of product. Maybe it will be used for a supplement. I don't know. Maybe it will be used for third generation type of product. So you produce PVC, maybe you could produce something else, and then you can produce the final product. We don't know yet. But what happens is every new normal requires the raw material. How do you process the raw material depends on how the demand is going to change. When I brought up this razor blade, there was copper, which was very much useful that time. There was steel, not steel, sorry. There was tin, which was very much useful that time. But things changed. The innovation brought new part. The thickness of the blade had to go down. New innovation came. The old, it had to give way by the old innovation. So now about the renewable energy. Yes, renewable energy is the way to go. The thing is that, even now for solar cells, if you look at the research that is going on, even the petrochemical industry is trying to enter into that market to capture a lot of radiation so that it can be converted either to the heat or to electricity. Now the coverage of the solar cell basically can be made out of PVC. Okay, so these things are happening. They are complementary. So to give you another view, yes, renewable energy, whenever there is a possibility, whenever it works technologically, economically, and in terms of demand, we need to invest on that one. But this product is not direct natural gas use for energy. This product is about natural gas converted to something else, then used in something else. No, I don't know. To be very honest, I don't know what happens in 5 years' time. Very honest, because you don't know when the situation is going to finish. When this situation finishes, what would be the demand? People come out, okay? What will be the demand for those people? The things can change, and it's not that people are sitting quiet. There is innovation going on now also inside many industry in order to reutilize or better utilize the same raw material that we are using today.
Well, thank you, Professor. I think in fact, I still have some more questions, but unfortunately, we have a very limited time, and I also don't want to put another pressure on you, Professor Shaligram. And I think Professor Ahmad Samir would like to have closing remarks, after your presentation, Professor Shaligram.
Sure. Thank you so much. Thank you.
It's your session, Professor Samir.
Okay, thank you very, very much, Professor.
Welcome. You're very much welcome.
Yeah, I think we have more time to discuss this, maybe another 5 days at least, right?
No problem.
Not just 1 hour, but we have limited time. So we hope that you would like to join us next time, okay, in the next session, the different topic.
No problem.
So we thank you very much for your kindness to share your knowledge. Thank you very much.
Thank you. Thank you. It's a pleasure. It's a pleasure to be able to talk to you and to meet you. I came to Jakarta many times, but never had this opportunity. So
yeah, visit us. We will have a guest lecture for you.
Okay. Thank you. Thank you so much.
Thank you, Professor Samil. And again, Professor Shaligram, we have learned a lot from you today, with this very valuable insights coming, from this webinar. And again, on behalf of BINUS Business School today, we would like to thank, and also on behalf of the participants, we have participants across Indonesia, and I believe some of them is also coming from your part, from Qatar. But we have definitely learned a lot from you, and I hope this will not stop here. So we will have we hope that we could have some more valuable sessions like this, Professor Shaligram.
No problem at all. You're always at the service, at your service. No issue.
Okay. Again, thank you very much, for your valuable time. And participants, the organizers have put some information for you related this e-certificate and SAT, especially for BINUS students. And herewith, we would like to conclude our webinar today. Again, thank you very much, Professor Shaligram, and I
Thank you.
hope we can meet, pretty soon.
Sure. Thank you, Professor Samil and Professor Ichsan. Thank you so much. Thanks to all the participants. I hope you liked it. Okay. Thank you.
Okay. Thank
And
you.
bye.
And yes. Bye-bye from Jakarta. Bye-bye.
Good night. Good night.